Hello team, today's challenge is idea rankings, where we're given an array of different ideas with optimistic, realistic, and pessimistic times, estimates, and we need to sort them in the shortest to longest amount of time, amount of expected time. And for that, we're absolutely going to do that. We're going to sort, and then we're going to pull out these names. Pretty easy stuff. Before we get into that, let's talk about the formula for a second. This optimistic, right? Optimistic plus 4 times realistic plus pessimistic divided by 6. This formula is actually a real formula. It is called the PERT formula, or the PERT formula. I'm not sure how you pronounce it. And those letters stand for Program Evaluation and Review Technique, something that I actually had to look up to remind myself of. So it's a real formula. It's kind of curious that they would compound it by adding the length of the idea name. That's not a real thing for time estimation, but they've tried to make it interesting, right? So this part here is very real. And if you're working with a good project manager, they're probably using this or some sort of a variant on it, right? So good to know where we should be estimating what happens if everything goes right, what happens if everything goes wrong, and what is most likely to happen, right? That's kind of what we're doing. The best, the worst, and the actual, okay? With that, I want to take just this part because it's a real formula. I want this to be its own thing, right? The times length of idea name, that's internal to our code. So we'll figure that out. But this is a real thing, so let's go and do that. Right up here, we're going to create a function just like this function. We're going to call it expected time and toss in return all of this, okay? To make it a little bit easy, we're going to grab this and just clean it up. So we get rid of all of this stuff, leaving optimistic with a comma, realistic with a comma, pessimistic. There we go. We have our formula. We could rename this to PERT time or something like that. Pick your names, right? Pick your names. From here, we can use that down in here. And again, I said that we were going to sort and then pull the names out. And the reason that we do that is because if you tried to do both at once, on the one hand, it gets way too busy, right? There's a lot of code in there. And on the other, why? I mean, JavaScript sort is already pretty fast. So why would you recreate a custom sort just to get the names out, right? I don't understand that, so I'm not going to do that. Instead, I'm just going to go sort, okay? We have A and B in here, and we return what? Well, we would return A minus B or B minus A, depending on which one we want, which way we want to sort. I always try to remember that A is smaller than B, right? It comes before B, so if you put A minus B, then you get small to big in terms of the sort. If you do B minus A, then you get a largest to smallest, right? So one is ascending, the other one descending. That's the words I'm looking for. But before that, we can't actually use A and B. We need to get this expected time, okay? So I've left this space in here so that we can do that. And I'm going to go A expect, just like this. We're going to send through expected time, and it's going to be a bit of a mess, right? We have A1, right? Not 0, but 1, because we're looking for that time, not the name. So the name is 0. Then we have 1, 2, 3, just like this. We're absolutely going to do that. Adding a comma, sending it out. Pasting so that we can just change some of these. This one's going to be 2, and this one is going to be 3, okay? And then, of course, we multiply that by a 0 dot length, right? And again, that's something that they want. That's not something that is a part of this very real formula that is used in project management, okay? So we need one of those for B. Let's go down here. Thankfully, everything should just work where we can multi-cursor this and get the B's in. If you can't do that, then change the name and change all of these values, B1, B2, B3, and B0, okay? And then down here, A expect minus B expect. Brilliant, okay? The last part is to pull out the names, right? So we can do that. That's going to be map. This is going to be our idea, and it's going to be idea 0, right? Just like up here, A0, B0, 0, the 0 index is where we keep the name. So we do that, and everything works. Before we wrap it up, I would like to do a little bit of cleanup, because while it's all in here, it feels very busy to me. As an example, this sort function, it feels very complex, very heavy, especially since we're reaching into expected time and then multiplying by the length of the name. So what I would do is I would pull that out right here. Okay, so I would go function and set this to sort by expected time, just like this, pasting it in, getting rid of this arrow because it doesn't matter, and everything should just work. A little bit of cleanup on the indents. Excellent. Okay, the wrapping's starting to look nice. Pasting that sort by expected time back in here without the brackets, right? Because it does that for you. It calls it for you. So just the reference to the function, not calling the actual function. And then, of course, making it work. So that works. Great. The other part is the sort itself. Okay. I'm sure that I've said this in other videos. I'll probably end up saying it in future videos as well. Sort is an in-place change, which means that we passed in ideas by reference. It was an array, so it's passed in by reference, which means that we have sorted ideas wherever that was called from, right? If we do analyze ideas and then we do something else with ideas down here, the order is going to be changed. It's going to be completely different because sort is in place. Map is not, but sort is. And that's very dangerous, right? We don't want to be changing things outside of our function. So we have two options here. We could expand this out and create a brand new array, right? That works. It still gets the job done. Or my preferred way, because we're using new JavaScript, is to go to sorted, and that will return a brand new array that we can operate on. Everything still works, but it is safer. Okay, if we're expecting the order of ideas to be a different way later on, well, we haven't changed anything, and that's exactly how I like to leave it. Okay. So again, this is today's code. We created a function for that PERT formula, the PERT formula, which is, again, it's a real thing, right? I had to remind myself of that because I'm sure that looks familiar. So I'm glad it's out there, and we can use it, right? The fact that they want to multiply by the length of the name, well, that's just a challenge, right? But we made that, and then we sorted, right? We did a sort on our array. That's all of this stuff using that expected time formula. So sorted from smallest to biggest, and then pulled out the idea name, right? Whatever that name is. And that is it, right? That's the whole thing. Again, not every solution, just hopefully one good solution. If you found others, if you liked it, if you hated it, again, as always, hit me up in those comments. Otherwise, today this is Idea Rankings, and I will see you in the next one.